Now let's take a look at part C of example 8.1. A psychologist feels that playing soft music during a test will change the results of the test. The psychologist is not sure whether the grades will be higher or lower. The problem states that in the past, the mean of the scores was 73. So if we assume that the mean has not changed, then we would have this distribution then, a normal distribution with the population mean right here in the middle, 73. And the question is, does playing soft music during this test change the results? Now the key phrase here is change the results. The results in the past have been that the mean is 73. If it is changed, then it is not 73. So the question is the population mean now not 73? Again, we are going to calculate a mean from a random sample. And when we find this mean, this sample mean, if it were to land somewhere close on either side of this assumed population mean of 73, then we would not necessarily be led to believe that the mean is not 73. Again, this is a sample, and we are going to incur sampling error. But if our population mean were significantly greater than 73 or significantly less than 73, then we would begin to believe that the population mean has changed and that it is no longer exactly equal to 73. So in this case, we see that we have a two-tailed test. Remember that the null hypothesis is the hypothesis that we would reject if we land in these rejection regions. Again, it is very unlikely that we would land way down here in this tail or way up here in this tail if the population mean is 73. And it's that unlikelihood that would lead us to doubt that the population mean is 73 and lead us to then conclude that the population mean is not 73. So our null hypothesis will be that the mean is 73. If we reject that, then our conclusion would be that the mean is not 73. Again, this is a two-tailed test because either way, significantly greater than or significantly less than 73 would not be equal to 73.